In this video, we will discuss the composition of two functions. So the composition of the function f with the function g is denoted by f circle g is really just f of g of x. So from an intuitive perspective, all we are doing is taking the function g and we're plugging it inside the function f. And note that once you've done this, if you wanted to determine the domain of this new function, you really do need two things to occur. You need x to be something in the domain of g, so that g of x makes sense. But at the same time, you need g of x to be in the domain of f. So let's look at a few examples. So in this first example, we're given the function f and g, and we would like to find g of f of x. So g of f of x, so we want to take the function f of x and plug it into the function g. And my favorite way of thinking about this is to once again replace that variable x with a blank box. And think wherever that blank box is, I need to plug in the function x minus 1. So this is g of x minus 1, and I have the function x minus 1 going in that blank box. So 3 over the quantity x minus 1 squared. Now, just for fun, let's go ahead and calculate f of g of x, i.e. f composed with g instead. So in this case, we want to take 3x squared and plug it into f. So we can think f of blank is blank minus 1. So f of g of x would be f of 3 over x squared. And I want to take that 3 over x squared and plug it in the blank for the function f. So this becomes 3 over x squared minus 1. And to simplify this a bit, we can rewrite the 1 as x squared over x squared. And this becomes 3 minus x squared over x squared. And the reason it was worth calculating the second composition, besides it just being fun, is that we can now very clearly see that the order in which we take the composition matters. G composed with f gives us a function different than f composed with g. Now, another observation we can make in terms of the domain. So for the domain of, let's say, f composed with g, you need something that we can plug into the function g. So the only thing we cannot plug into g would be x not being equal to 0. And any output of g needs to be in the domain of f. But the domain of f would be every possible real number. So I'll say all real, or you could denote this as minus infinity to infinity. So the domain would be minus infinity to 0 union with 0 to infinity. For these two given functions, let's go ahead and compute f composed with g. So f composed with g is f of g of x. So we want to take the g of x function, 2 over x minus 3, and plug that into f. So f of something is that something squared plus 1. And the something we are plugging in is 2 over x minus 3. So 2 over x minus 3 squared plus 1. And now let's go ahead and simplify. So we can distribute that square to the top and the bottom. And when we add these fractions together, what we are going to want to do is rewrite the 1 as x minus 3 squared over x minus 3 squared. So we now have a common denominator, x minus 3 squared, and we just need to combine terms appropriately in the top. So x minus 3 quantity squared is x squared minus 6x plus 9 But remember, along with that plus 9, we have a plus 4. So that ends up with plus 9 plus 4, which is a plus 13. Now asking the question from a different perspective, and this is going to be something very important when we get to something called the chain rule in the calculus portion of the course, is that if you have a function, big F, can you find functions little f and little g that express it as this composition? The idea is, can we identify what we might think of as the inside function g and the outside function f? And note there's typically multiple answers to these problems. So for the first one, my observation is that I see this x plus 3, which is inside something. So that makes it a good choice for the g function. The question then is, what function is it inside? Well, if I replace that x plus 3 by a blank, the function would be 1 over blank squared. So 1 over x squared. Now note, just for fun, we could double check this answer. You say, okay, f of g of x is f of x plus 3. And when you plug into the f function, everything that goes in for the x is going to end up being squared in the denominator. So 1 over x plus 3 squared. Check. With the second example, one thing I'm immediately noticing as an inside function would be this x squared minus 4. It's inside the square root. So the inside function would be the g. The function on the outside would be the square root of x. And with this choice of little f and little g, we get big F of x is f of g of x.